the basic need for knowledge representation in artificial intelligence. We've seen how knowledge representation plays a very important role in artificial intelligence by looking at several kinds of knowledge representations in context of several applications. Classically, knowledge representation has been a very core area of research in AI and also in terms of application, because the format of the knowledge which you represent will also represent the effectiveness of the corresponding system by looking at how useful it is for the target AI concept. So most successful AI systems in the past, before the current trend of more ML-driven systems, has been the era of expert systems. So if you see expert systems, the basic idea of expert systems has been on the development of knowledge systems in the form of expert rules, where rules can be considered as a set of statements of the form if X, Y, and Z, then T means do something. So the idea is a rule is a domain expert driven knowledge artifact which is used to capture the expert's knowledge in form of a rule like this, and when you see an input condition satisfying some things on the left hand side, you will also trigger the corresponding right hand side system. So a lot of expert systems in the history of systems-based knowledge systems in the context of AI, first generation AI systems in the late 80s and early 90s, which were successful, were based on this notion of knowledge being represented as a collection of handcrafted set of rules which dictated the core knowledge contained corresponding to a particular system. So there, domain users used to come and encode this knowledge in form of collection of these rules and develop a corresponding expert system for each domain. For example, we had an expert system for a specific kind of a disease like cancer, or a domain-specific expert system for treating something like, say, tax competition for a specific country. Like that, we had several expert systems for individual domains, including one very popular expert system called MySyn, which is basically a medical expert system, which is based on a whole bunch of collection of medical rules encoded in form of a rich knowledge like this. But then are rules the only form of domain knowledge representation which is useful? For sure, are they useful even in today's ML world? I would say yes, because if you see today's ML world, decision trees as a knowledge representation technique, they are basically looking at representing a whole bunch of rules concisely represented in form of a decision tree. So in that sense, rules are not going away. So rules are still a powerful form of knowledge representation in the context of AI systems. Going beyond rules, what are the other forms of knowledge representation which are currently used in concepts like ML and DL, etc.? One interesting approach has been to use something like equations or expressions which are linear. So, for example, we can have an equation like y equal to m2x2 plus m1x1 plus m3x3 so on plus c as an equation representing an output function in terms of several input functions as approximating the original input value. So in that sense, a knowledge representation in form of a collection of coefficients and an intercept becomes the underlying knowledge representation for the whole bunch of input knowledge contained in a whole bunch of input data. Moving on, we can have other forms of knowledge representation like what we studied in diagnosis, where we said that suppose you have a symptom, you have two different causes, cause 1, cause 2, with some weight. in 0.2 times this is possible due to cause 1, 0.8 times due to cause 2. This again can be cause to 1, to 2, 0.3, 0.7. So this is more like further root causes of an existing cause, which is again a symptom of these two causes. So this kind of a weighted network is a very common nowadays in diagnosis, is called as a Bayesian network. Bayesian network is basically a cascaded set of, typically it is directed, it's like a directed acyclic graph, where you have symptoms at the leaf and you have a lot of nodes connected to each other, representing a set of cause-effect hierarchy of relationships. Moving on, there are other kind of knowledge representations which is very popular in deep learning, which is basically a set of input neurons and multiple layers of neurons connected to each other by weights. The way this is used in deep learning is called a neural net. A neural net is typically consisting of several layers between an input layer and an output layer, and each layer connected to the previous layer by a set of directed edges, each edge containing a weight. And the idea is that the linear function, which ultimately is a result of combination of all the previous computations, gives rise to some value here, which is output here and here, which is then compared with the target original output and compared to how much error it is, and then based on that you try to revise the weights in the network, and ultimately you stabilize to some collection of weights in the network. That becomes a form of knowledge representation for the deep learning phenomenon. And this has humongous power, especially when it comes to unstructured data like speech, video, audio, image, or even driverless cars, etc. Neural networks are very powerful forms of knowledge networks, which are very useful in the context of what we call as deep learning systems. So if you see, knowledge representation in the context of AI systems has several forms. There's no one form fits all. Or for example, you can have in the form of a constraint optimization, you can have a simple equation like all different xy, which is basically saying that it is a binary relationship between any two variables in the input, which says that both of them should be different. Or you can have a simple saying equation which says that xy can only take, say, combinations like. So this becomes a constraint, which is a collection of possible allowed value combinations in the problem, and that becomes an input to the corresponding optimizing problem. So if you see here, we're talking about a relational schema as representing the corresponding constraint. So if you see, the paradigm of knowledge representation can be in multiple facets. For example, in decision trees, as we saw, we can have simple things like there's a top level variable, then we can say if x is less than 2, x greater than or equal to 2, form different branches, then you form based on y less than or equal to 1, y greater than or equal to 1, then you can form here z greater than or equal to 2, z less than 2. So if you see, this is a decision tree which represents a hierarchically dividing the solution space into a set of cascading behaviors. So if you see, we have covered several variants of the knowledge representations which are useful in the context of AI. Started with rule-based systems, which are basically a collection of if-then-else kind of thing. We can have binary constraints, we can have neural networks, we can have equations, we can have decision trees. So these are just some of the more popular variants of the knowledge representations which are useful in the context of AI systems.